Hi, here we are again. Lesson 2, Division Alternative Strategies. This is an example of a homework sheet you may have seen come home a couple of weeks ago, and there was one last week like this. It has a variety of problems on it, but number 3 is a division problem, and it says David has 289 M&Ms. He wants to put equal amounts of M&Ms into 8 goodie bags. How many M&Ms will he put in each bag? Well, this is how you would set up the problem for the standard long division algorithm. And many of your children do not know how to do that yet. Several students know partial quotients, and I'll show you that strategy next. But I want to show you that you can help your children divide without teaching them a standard algorithm at all. One strategy would be to draw out 8 goodie bags. That's totally acceptable, and many children use this. And we would think, what is the largest number that we could put in each bag if we have 289 M&Ms? 289 M&Ms. Could we put 100 in each goodie bag? No. Could we put 50 in each goodie bag? 50, 100, 150, 200, 250, 300. So we can't even put 50 M&Ms in each bag. So let's try 20. 20, 40, 60, 80, 100, 100, 120, 140, 160. Okay, so I've used 160 M&Ms. So I have 129 M&Ms left over. So I know I can't put 20 more M&Ms in each bag because 20 M&Ms in each bag used 160 M&Ms. So now I'm going to try 10. 10, 20, 30, 40, 50, 60, 70, 80. Okay, so I need to subtract the 80 M&Ms that I've given out. So I have 49 M&Ms to give out. So can I put 2 more M&Ms in each bag? Can I put 5 more M&Ms in each bag? 5 times 8 is 40. Okay, so that sounds like that's going to work. 5 M&Ms in each bag. And I see that I've used 40. And I have 9 M&Ms left. So how many M&Ms can I put in each bag? I can put 1 more M&M in each bag. And that took care of 8. And so I know I have a random leftover M&M that I'm just going to eat. And so each bag holds 20, 30, 35, 36. So the answer is 36 M&Ms per bag with 1 M&M left over. Okay, so let's look at a partial quotients method. It's very similar to drawing the picture with the goodie bags, except you record it in a standard algorithm like this with the division symbol. I call this the doghouse division symbol versus the horizontal written division problem. And the children record the products, the partial products on the side, or the partial quotient, partial quotients, because the quotient is the answer to a division problem. And so we're going to do the same thing. We can put 20 M&Ms per bag first, and 20 times 8 is 160, 160. I subtract and get 129. Okay, so I have 129. How many M&Ms in each bag? I'm going to try 10 more in each bag. 10 times 8 is 80. I subtract and get 49. And then I know that I can put 5 more in each bag. 5 times 8 is 40. 9 left over. And I can put 1 in each bag. 1 times 8 is 8. Subtract and have a remainder of 1. and we add these together. 20, 30, 35, 36. 36, remainder 1. Let me take this opportunity to show you a check problem. So I love it when children put their check mark, so I understand that that's a check problem. And the check problem would be the answer, 36 times 8. 6 times 8 is 48. And 8 times 3 is 24. But this isn't a 3, it's a 30. 8 times 30 would be 240. And then I add my remainder, my 1 M&M left over, and I get 289. Now this is kind of backwards. I'm not going to redo the video, but I totally should have estimated before I began this problem. So let's do that right here. Let's go back and do our estimates, a little out of order. Thinking about 8, what times 8 gets me close to 28? And I know that 3 times 8 is 24, and 4 times 8 is 32. So 4 is going to be too big if I'm looking at this. So I'm going to say, change this to 240, because 24 is really friendly with 8. Okay? So 289 becomes 240 divided by 8, and I know that 3 times 8 is 24. So 30 times 8 is 240. So a reasonable answer would be 30, and our exact answer is 36. And that's our mini lesson on division.